Hello and welcome back. Welcome back. I'm John, an old YouTuber and PC gamer. Start to getting dark. It's a little bit more than 9 p.m. And I did not save, I forgot that. I did have to save a lot of PDF. But many people have to go to work Sunday evening. Many have to go to work tomorrow. They maybe go to bed before 11 p.m. So I have to keep my voices a little bit down on this computer voice. So we have to stop. We have to stop do this in like 1 hour and keep quiet. Yes, we have the news in the Danish television. It's 9 p.m. It's actually now. So the news stops about 9:30. So probably I think we should be quiet a little bit after 10 p.m. So I don't know which one I should take. Yes. No, it takes like 6 hours to charge this camcorder. So, and we already record like 1 hour. I have not downloaded, I have to download this, so if my computer is logging, I can go get it back. I'll only lose this one. But I don't know, that's the Fairchild Semiconductors, or that's 6 pages. I don't know, should we do the big one? Fairchild Semiconductors. That will probably take more than 1 hour. Because we just make this Federico Fagins. He made the Intel 4004 and the 4040 and 8080. So I was thinking about to do this Fairchild Semiconductor, then do the Intel 4040. Then we need to know what is 4-bit computing, what is 8-bit computing. But we got the Zilog, the Z80. So, but we did this fagging there. I cannot do this with one hand, so I have this weird nose there. So let's just continue. Yes, I do this because I think it could be helpful for many like me. I'm not English, I'm an old Danish YouTuber and gamer, and that's much more easy to understand English if somebody reading it loud with a real English voice. So I have to. Yes, but we don't have much power. I don't know if we have power enough to do this. But let's start. Read to the end of the document.
Fairchild Semiconductor. Fairchild Semiconductor. International, Incorporated Fairchild Semiconductor logo.svg. Type public traded as NASDAQ, Industry Semiconductors. Computer networks. Lighting. Circuit protection. Founded 1 October 1957. Founder Sherman Fairchild. Arthur Rock. Defunct mid-September 2016. Fate acquired by On Semiconductor Headquarters 1272 Borigasave, Sunnyvale, California, United States. Area served worldwide. Eki people. Mark Thompson, Chairman and CEO. 1. Mark Esfrey, Executive Vice President, CFO and Treasurer. 1. Products: integrated circuits, signal processors, motor controllers, field effect transistors. Revenue decrease. US $1.370 billion. 2015. 2. Operating income decrease. $6 and 30 cents million. 2015. 2. Net income decrease. US minus 15.1 million. Fairchild Semiconductor International, Inc. was an American semiconductor company based in San Jose, California. Founded in 1957 as a division of Fairchild Camera and Instrument, it became a pioneer in the manufacturing of transistors and of integrated circuits. Schlumberger bought the firm in 1979 and sold it to National Semiconductor in 1987. Fairchild was spun off as an independent company again in 1997. In September 2016, Fairchild was acquired by ON Semiconductor. 3. The company had locations in the United States at San Jose, California, San Rafael, California, South Portland, Maine, West Jordan, Utah, and Mountaintop, Pennsylvania. Outside the US it operated locations in Australia, winking sad smiley 4, Singapore, Busan, South Korea, Penang, Malaysia, Suju, China, and Cebu, Philippines among others. Contents. History 1950s, 1960s, 1970s, 1980s, 1990s, 2000s, 2010s. Alumni. See also. References. External links. History. 1950s. In 1955, William Shockley founded Shockley Semiconductor Laboratory, funded by Beckman Instruments in Mountain View, California. Winking sad smiley 5. His plan was to develop a new type of 4-layer diode that would work faster and have more uses than then current transistors. At first he attempted to hire some of his former. 2015. 2. Total assets decrease. $1 and 58 cents billion. 2015. 2. Total equity decrease. $1 and 10 cents billion. 2015. 2. Number of employees 9,000. Parent ON Semiconductor. The historic marker at the Fairchild building at which the traitorous 8 set up shop and the first commercially practical integrated circuit was invented. The building at 844 East Charleston Road, Palo Alto, California, where the first commercially practical integrated circuit was invented. Colleagues from Bell Labs, but none were willing to move to West Coast or work with Shockley again at that time. Shockley then founded the core of the new company with what he considered the best and brightest graduates coming out of American engineering schools. While Shockley was effective as a recruiter, he was less effective as a manager. A core group of Shockley employees, later known as the Traitorous 8, became unhappy with his management of company. The 8 men were Julius Blank, Victor Greinick, Gene Hurney, Eugene Kleiner, Jay Last, Gordon Moore, Robert Noyce, and Sheldon Roberts. Looking for funding on their own project, they turned to Sherman Fairchild's Fairchild Camera and Instrument, an eastern U.S. company with considerable military contracts. 6. In 1957 the Fairchild Semiconductor division was started with plans to make silicon transistors at a time wherein germanium was still the most common material for semiconductors. According to Sherman Fairchild, Noyce's impassioned presentation of his vision was the reason Sherman Fairchild had agreed to create a semiconductor division for the Traitorous 8. Noyce advocated the use of silicon as substrate since the material costs would consist of sand and a few fine wires. The major cost would be the manufacturing process. Noyce also expressed his belief that silicon semiconductors would herald the start of disposable appliances that, due to cheap electronic components, would not be repaired but merely discarded when worn out. 7. Their first transistors were of the silicon mesa variety, innovative for their time, but exhibiting relatively poor reliability. Fairchild's first marketed transistor was the 1958 2N697, a Mesa transistor developed by Moore, 8, and it was a success. The first batch of 100 was sold to IBM for $150 apiece in order to build the computer for the B-70 bomber. More were sold to Autonetics to build the guidance system for the Minuteman ballistic missile. 9. At the same time, Gene Huerny developed the planar process, which was a major improvement. Transistors could be made more easily at a lower cost and with greater performance and reliability. The planar process made most other transistor processes obsolete. One such casualty was Philco's transistor division, whose newly built $40 million plant to make their germanium pad process transistors became a non-viable. Within a few years, every other transistor company paralleled or licensed the Fairchild planar process. Huerny's 2N1613 was a major success, with Fairchild licensing the design across the industry. In 1960, Fairchild built a circuit with 4 transistors on a single wafer of silicon, thereby creating the first silicon integrated circuit. Texas Instruments' Jack Kilby had developed an integrated circuit made of germanium on the 12th of September, 1958, and was awarded a U.S. patent. However, Kilby's method was not scalable, and the semiconductor industry adopted Fairchild's process to manufacture integrated circuits. The company grew from 12 to 12,000 employees, and was soon making $130 million a year. 1960s. Fairchild's Noyce and Texas Instruments. Kilby had independently invented the integrated circuit, IC, based on bipolar technology. In 1960, Noyce invented the planar integrated circuit. The industry preferred Fairchild's invention over Texas Instruments because the transistors in planar ICs were interconnected by Avene film deposit, whereas Texas Instruments' invention required fine wires to connect the individual circuits. Noyce's invention was enabled by the planar process developed by Gene Huerny. 10. In turn, Huerny's planar process was inspired by the surface passivation method developed by Mohammed Attila at Bell Labs in 1957. 11. In the early 1960s, Fairchild R&D began experimenting with the MOSFET, metal oxide semiconductor field effect transistor, also known as the MOS transistor. The first MOSFET was invented by Mohammed Attila and Dawan Khan at Bell Labs in 1959, and demonstrated in early 1960, 12, but was initially overlooked and ignored by Bell Labs. 13. However, the MOSFET generated significant interest at Fairchild. Inspired by the first MOSFET, Jitang Sa built a MOS-controlled tetrode at Fairchild later that year. MOS devices were later commercialized by Fairchild in 1964, with P-channel devices for logic and switching applications. 12. The experiments led to Fairchild's development of MOS integrated circuits. 14. In 1963, Fairchild hired Robert Widler to design analog operational amplifiers using Fairchild's process. Since Fairchild's processes were optimized for digital circuits, Widler collaborated with process engineer Dave Talbot. The collaboration resulted in 2 revolutionary products, A702 and A709. 15. Hence, Fairchild dominated the analog integrated circuit market, having introduced the first IC operational amplifiers, or op-amps, Bob Widler's A702, in 1964, and A709. In 1968, Fairchild introduced David Fulliger's A741, which became the most popular IC op-amp of all time. 16. By 1965, Fairchild's process improvements had brought low-cost manufacturing to the semiconductor industry, making Fairchild nearly the only profitable semiconductor manufacturer in the United States. Fairchild dominated the market in DTL, op-amps and mainframe computer custom circuits. In 1965, Fairchild opened a semiconductor assembly plant on the Navajo Nation in Shiprock, New Mexico. 17. At its peak, the plant employed over 1,000 Navajos, the majority of whom were women. In the Shiprock dedication commemorative brochure released by the Fairchild Company, the Dime Navajo women circuit makers were celebrated as culture workers who produced circuits as part of the reproductive labor of expressing Navajo culture, rather than merely for wages. This claim was based on the opinion that circuits of the electronic chips had a mere resemblance with the complex geometric patterns in the Navajo rugs. Paul Driscoll, the Shiprock plant manager, spoke of the untapped wealth of natural characteristics of the Navajo, the inherent flexibility and dexterity of the Indians. Although highly successful during its operation, the plant was closed in 1975. 18. While the Fairchild Corporation claims fed-in women were chosen to work in the Shiprock plant due to their nimble fingers, as previously noted, the women of the Shiprock reservation were actually chosen as the workforce due to a lack of labor rights asserted by the women, in addition to cheap, plentiful workers and tax benefits. 19. Fairchild had not done well in the digital integrated circuit market. Their first line of ICS was the micrologic resistor transistor logic, RTL, line, which was used in the Apollo guidance computer. It had the advantage of being extremely simple. Each inverter consisted of just one transistor and two resistors. The logic family had many drawbacks that had made it marginal for commercial purposes, and not well suited for military applications. The logic could only tolerate about 100 millivolts of noise, far too low for comfort. It was a while before Fairchild relied on more robust designs, such as diode transistor logic, DTL, which had much better noise margins. Sales due to Fairchild's semiconductor division had doubled each year, and by the mid-1960s comprised two-thirds of total sales of the parent company. In 1966, Fairchild's sales were second to those of Texas Instruments, followed in third place by Motorola. Noyce was rewarded with the position of corporate vice president and hence became the de facto head of the semiconductor division. However, internal trouble at Fairchild began to surface with a drop in earnings in 1967. There was increasing competition from newer startups. The semiconductor division, situated in Mountain View and Palo Alto, California, was actually managed by executives from COSET, New York, who visited the California sites once a year, even though the semiconductor division earned most of the profits of the company. Fairchild's president at that time, John Carter, had used all the profits to fund acquisitions of unprofitable ventures. Noyce's position on Fairchild's executive staff was consistently compromised by Sherman Fairchild's faction. Charles E. Spork was Noyce's operations manager. Spork was reputed to run the tightest operation in the world. Spork, Pierre Lamond and most managers had grown upset and disillusioned with corporate focus on unprofitable ventures at the expense of the semiconductor division. Executives at the semiconductor division were allotted substantially fewer stock options compared to other divisions. In March 1967, Spork was hired away by Peter J. Sprague to National Semiconductor. Spork brought with him 4 other Fairchild personnel. 20. Actually, Lamond had previously assembled a team of Fairchild managers in preparation to defect to Plessey, a British company. Lamond had recruited Spork to be his own boss. When negotiations with Plessey broke down over stock options, Lamond and Spork succumbed to Widlers and Talbots, who were already employed at National Semiconductor, suggestion that they look to National Semiconductor. 21. Widler and Talbot had earlier left Fairchild to join Melectro, which was later acquired by National Semiconductor. 22. In the fall of 1967, Fairchild suffered a loss for the first time since 1958 and announced write-offs of $4 million due to excess capacity, which contributed to a total loss of $7.6 million.